Greetings to all my YouTube viewers. Today's topic is going to be on photonic crystals. Scientifically, we should know what is this crystals had properties earlier. So if you see here, crystals, the beginners of crystals, if you see, there were many crystals which were used for healing properties in those days. See, if I hear crown chakra, the third eye chakra and all, amethyst crystal was used for some healing properties from ancient days. Egyptians were using these crystals for healing properties in very old times also. And currently, if you see the DNA structure, the adenine, thymine, cytosine, all these are, which is like marked here, tubular structures, they are all crystals. So metalloids like silicon, boron, germanium, antimony, we know these are special semiconductor crystals. Today, if we don't have any silicon or germanium, there is no electronics industry or there is no photonic industry. The mobile phone, what we enjoy now, the laptops, what we enjoy now, is made up of some semiconductor devices. So these crystals, silicon and germanium, are semiconductor crystals, novel semiconductor crystals, without which today there is no mobile phones technology or the laptop, nothing. We will not have enjoy any electronic gadgets without these crystals. So this is the very ancient the analog watches where you can see the quartz crystal being embedded here. It was having some time properties and they had the circuit here. This quartz crystal was charging and discharging. Due to this property, it was used in the watches. Photonics applications. Photonics is a branch of optics that involves the application of generation, detection, and manipulation of light in the form of photons. So these photons, because of its emission, transmission, modulation, and all, we were able to tune the properties of these photons, and the study of these photons is basically the photonics. So, in simple, we were able to tune the properties of the light and study in detail. Lasers, optical fibers, the camera screens in our mobile phones, optical tweezers, the lighting in our covers, homes, computer screens, the TV, they are all example of photonics. Photonic devices affect a very wide range of applications. Telecommunications is heavily dependent on photonic devices only. So photonics is a physical science of light waves. It deals with the science behind the generation, detection, and manipulation of light. We have many applications of photonics actually in daily life, which is being screened here. So in near future, now we are all having Wi-Fi. In near future, it will be Li-Fi because of this light wave properties. So every day there is research going on with the light waves, and how well we are able to tune these light waves and study on that is nothing but photonics. So now we know the crystals. Basically, crystals are nothing but they have regular arrangement of atoms. A solid is actually divided into amorphous and crystalline. When you call a solid as a crystal, only if the atoms are arranged in a regular, repetitive manner. So what is this photonic crystal? Photonic crystal is nothing but the crystal composed of nanostructures of periodic dielectric or any refractive index that affects the propagation of photon in the same way as the periodic potential in a semiconductor crystal affects the electron motion. Okay, so that is called a photonic crystal. How in a semiconductor crystal, when you have the movement of photon, it gets affected by the electron movement. So when you pass an electric field in the semiconductor crystal, it affects your movement of electrons because of light waves. So the interaction between the photon and electron in a semiconductor crystal, just like that, your photonic crystal will be how the molecules and nanostructures are getting affected because of the light waves. They are nothing but photonic crystals. So you could see here what are the applications of photonic crystals means. You have biomedical applications, sensors, anti-counterfeiting, then textile, display properties, smart windows. A photonic crystal is an optical nanostructure. So it is not a very big crystal as we say. It is a very optical nanostructure in which the refractive index changes periodically. This affects the propagation of light in the same way as that of a natural crystal. We know about the X-rays, how X-rays were sent to a crystal and how it is affecting the structure of a crystal. Through that only we study the properties of crystal. Similarly, this photonic crystal is also a optical nanostructure where the refractive index will change periodically. It is also having a, it is also, you can say, the dielectric properties are also getting affected with respect to your changes in the refractive index. So it is mentioned here. It is a photonic crystal where the dielectric, or which is like a dielectric crystal, means, there is no conduction of electricity, which has a periodic division of refractive index where the span of period is of the range of wavelength of light. Photonic crystals occur in nature and control how photons are absorbed or reflected. These are made up of dielectric nanostructures which will permit specific wavelength of light to pass through, and remaining all other wavelength of light will be like hindered. So you can see the 1D photonic crystal, 2-dimensional photocrystal, and 3-dimensional photonic crystals. The history behind the photonic crystal is that they are being studied in one form or another since 1887 onwards. So you have Ablotovich and Sanjeev John. They published two milestone papers on photonic crystals in 1987. And Vladimir Bykov was the first to investigate on this photonic crystals. He developed the concept of three-dimensional photonic crystals also. So you can see here they have a periodic structure which is leading to the formation of photonic band gap, and they have very remarkable optical properties like omnidirectional reflection, slow light, unusual chromatic dispersion, and peculiar refraction effects. The waveguides, resonators, or other features can be introduced as devices, the lattice defects, making the technology very interesting. In 1991, Yablonovich had demonstrated the first three-dimensional photonic band gap in the microwave regime. The structure that he was able to do was by involving or drilling an array of holes in the transparent material, where the holes of each layer form an inverse diamond structure. And in 1996, Thomas Cross demonstrated two-dimensional photonic crystal at optical wavelengths. So in 1996 itself, we were able to discover the two-dimensional photonic crystals. Until now, you could see there are many advanced researches being conducted on these photonic crystals. And every day we are finding the new usage of this photonic crystal. So playing with photons by tuning its propagation inside the materials, it is giving rise to interesting properties. So if you see the examples of photonic crystals, opals. Opals, it has been shown here. See, they are natural examples of photonic crystal. The regular arrangement of silica spheres and opals causes the interference of light waves, leading to characteristic play of color. You could see this regular arrangement of silica spheres. So here, because of the interference of light, you can see different shades of color being like, imprinted. This is one property that is giving you the crystal a very colorful nature. The butterfly wings. See, the wings of certain butterflies, such as the morpho butterfly, they have microscopic scales that act as a photonic crystal. So what happens is, because light enters this crystal, the refractive index changes layer by layer, and they emit different colors. Okay, the scales create very vivid iridescent colors due to the interaction of light with their nanostructured surfaces. Then the other one is a synthetic photonic crystal. Here, this has been developed artificially by the researchers by using various materials, including the dielectric and semiconducting materials. These crystals can be engineered for specific applications. They have more controlled properties. What is the importance or the significance of photonic crystal? Basically, it is used in optical communication. Photonic crystals have applications in the field of optical communication. You can control the propagation of light, as they can be used to create efficient and compact photonic devices such as wavelength, filters, and modulators. Then it is used in sensors. Photonic crystals are employed in the development of highly sensitive sensors. The ability to control and manipulate light within the crystal structure, it enhances the detection of changes in the environment. So, sensing always means something like you are able to measure through some property. So you are able to control and manipulate a light within the crystal structure by only sensing the changes in the environment, which is making these crystals to be applied in the sensing applications. Then integrated optics. Photonic crystals can be integrated into microchips to create a very compact and efficient optical circuits. This is very crucial for the development of faster and more efficient information processing technologies. You know what is information? Information is wealth these days. And how well you're able to process this information? We say optical communication is the fastest communication. In near future, you will have this integrated optics communication also using a photonic crystal. Light emitting devices. Photonic crystals are used in the design of efficient light emitting devices such as lasers and LEDs. The control of light propagation helps improve the performance and efficiency of these devices. Then the solar cells. Photonic crystals will increase the efficiency of a solar cell by controlling the absorption and emission of light. See, in all these applications, I have given only the basic science behind these photonic crystals and how it is employed in these applications so that we can realize the significance of this photonic crystal. So how you are able to apply this in a solar cell? It is led by improving some light trapping, which is beneficial for increasing the energy conversion, mainly the solar energy conversion. Then it is used in the quantum information processing. Photonic crystals play a role in the development of quantum information processing technologies. They are used to manipulate and control photons, which are essential for quantum communication and quantum computing. In summary, photonic crystals have diverse applications ranging from optical communication and sensors to integrated optics and renewable energy technologies, making them a very significant area of research and development in the field of photonics. So what is the ongoing research in photonic crystals you should be knowing? So it is used in metamaterials and tunability. Researchers are investigating the metamaterials with unique optical properties by designing the photonic crystals with tunable features. So it is, we are able to manipulate the band gap or alter the properties of photonic crystal, which is a real time, it is actually a very crucial one, especially in your reconfigurable photonic devices. It is used in quantum information processing, as I told earlier. It is used in nonlinear optical effects. So, investigating a nonlinear optical effects in photonic crystal will be the focus of research. Understanding and utilizing nonlinear interactions within these structures can lead to the development of efficient frequency converters, optical parametric amplifiers, and other nonlinear optical devices. So, photonic crystal fibers. Researchers are going to explain or they're going to explore the design and optimization of photonic crystal fibers for various applications, including telecommunications, sensing, and superquantum generation. These fibers offer unique guidance properties. It could be tailored for even specific wavelength regions. So how we are able to fabricate your photonic crystal, how we are able to tune them, what are the applications? Again, the same old. It is used in integrated photonics. It is used in biophotonics. See, it is all used in the field of biophotonics, biosensing application. So we wanted some photonic crystal based sensors for detecting the biomolecules, pathogens, and other substances with very high sensitivity and specificity. Integrated photonics, we have already seen in the earlier slides. Topological photonic crystals. So it is used in the field of topological insulators in electronics, and scientists are exploring how well you can tailor this material for these different applications. Energy harvesting. Photonic crystals are investigated for their role in enhancing light trapping and absorption in solar cells. Researchers are aiming to improve the efficiency of energy harvesting devices by controlling and manipulating light within the photonic crystal structures. So this is the 1D photonic crystal. This is the we call it as a Bragg grating. So a fiber Bragg grating, FBG. It is a distributed Bragg reflector. So where you have short segments of optical fibers, it reflects particular wavelength of light, whereas it transmits all others. So a fiber Bragg grating is used in the inline optical filter, where you can block certain wavelengths and release or transmit the other radiations. The first in-fiber Bragg grating was demonstrated by Ken Hill in 1978. The principle behind this is a Fresnel reflection, where light traveling between media of different refractive indexes will both or may both reflect and refract at the interface. So this is the other 1D photonic crystals, which is used as a optical coupler, we say. It is used as an optical coupler. Some groups are using as a Bragg reflector. So this is the slide showing about how it could be used in the optical, coupling. This is a 2D photonic crystal. They are typically made up of simple one-layer planar fabrication of process. So they have in fact more applications than three-dimensional photonic crystals. Here, holes may be drilled in a substrate. You could see these holes. They are drilled in a substrate such that such that the wavelength of radiation that the band gap is designed to block. The triangular and square lattices of holes have also been successfully employed. The holy fiber or a photonic crystal fiber can be made by taking cylindrical rods of glass in hexagonal lattice and then heating and stretching them. There will be triangle-like air gaps between the glass rods, which will become the holes that confines the modes. So you could see the SEM micrograph of a photonic crystal fiber produced at a US Naval Research Laboratory. You can see the diameter of the hole is only 4 micron meter. Photonics in India. So if you could see here, the Center for Research and Nanotechnology and Science, CRNTS, in IIT, Professor R. Vijaya had initiated experimental work in this area in 2004 with the funding from Department of Science and Technology, Government of India, DST. The bulk sedimented photonic crystal samples showed very good ordering, but they were not very much suitable for photonic studies. The thin film photonic crystals synthesized by the convective self-assembly method and horizontal inward growing self-assembly method have shown very good optical and structural characteristics apart from being mechanically stable also. So the 3D ordered photonic crystals have been prepared in this laboratory from IIT, and the research team from the Center of Nano and Soft Matter Sciences in Bangalore, an autonomous institution of the Department of Science and Technology DST, has shown an elegant pathway to achieve complete photonic band gap and then the simple and cost-effective methodology developed by the team led by Dr. Geeta Nair involves ingenious ways of incorporating high refractive index nanoparticles of appropriate shape and size in the blue phase liquid crystal. The spherical shaped selenium nanoparticles is also like, with a very high refractive index also can go into the cores, and they are also very effective in their refractive index changes. And all these results were published in the journals, and these are the research happening in India at these laboratories. This is a new field of research. All I wanted to say is, apart from different field of research, this photonics is gaining much more significance, and I wish all physics students could act. I would like to say this is the new research field for physics students. If you are going for any research field looking in for nanotechnology, photonic crystals is the best, research field where you could look in for ways of synthesizing the photonic crystals in the cost-effective methods. And the next is tuning the different properties of these photonic crystals. How light is affecting the refractive index of the, photonic crystals. How it is like giving changes to the structure, and what are the other tunable properties of light which you could study, can all be like dealt with. So just like a AI, this photonic crystal is going to be the near future, because today we have something like Li-Fi and optical fibers and then photonics, where these photonic materials will be very useful and conquering the whole research field in the near future. With these words, I'm just taking signing off, and I really thank all the viewers. Please give in your likes, shares, and comments, and thank you all.